So how many people here remember around November last year, Twitter sign-up was broken for almost 2 days? This is awesome. Usually at this point, there is someone in the room who raises their hand, and then I have to say that never happened. And this is part of the reason why it didn't happen. Yeah, so glad to be standing amongst you guys today. Yeah, I did this at LinkedIn and a bunch of other places, and everybody, every time there's one person who raises their hand, it's like falls for it. Anyway, so at Twitter, at the very least, I mean, and I imagine this being the case across the industry, you make a change to your service, and then you're wondering whether you've broken something inadvertently, and all your unit tests are passing, but you still like some more confidence, and what else can you do? If you're an SRE in DevOps and you have an even bigger problem, then you're thinking, this is somebody else's code. They made changes to it. I don't even understand what the changes are. And I have to make the decision as to whether or not this code is OK to be deployed or not. And maybe I'll canary something and see how it behaves compared to the rest of the stuff. But basically, pushing changes out to production is a scary thing. And anything we can do as developers to minimize that risk, we should do. Our first line of defense naturally comes out to be unit tests, tightly scoped tests, let's say a single method or a class in isolation. And for the purpose of this conversation, let's say we focus on path coverage. So let's say you have a method that you're trying to test that has five possible code paths. Then writing one test gets you 20% coverage, and you write 5 tests and you're done. But oftentimes it can take you more time to write good tests than actually writing the code that is being tested. So I mean, it's a little bit expensive, but it's still doable. Then you get more aggressive and more ambitious with the level of certainties you want about the behavior of your service, and you're saying that when a request hits my service, it's probably going through in this example 6 different methods, and each method has, let's say, 5 different independent code paths. So the combined number of possible code paths, so the cyclomatic complexity, if you will, for something like this would be of the order of 15,000 possible paths. And no one is probably motivated enough to write 15,000 tests for anything. So basically, right, like writing a test by hand at this point is becoming less valuable. You only get 0.03% coverage. And if you get to the point of integration tests where you have, let's say, 4 services in your stack, and now you want to look at the composed behavior of all the services, then it's so infinitely large a number that if I take the example of one of our largest running services in production, it would take us about 1,000 years processing requests at the rate, or running tests at the same rate as the services processing requests to get full coverage. That's assuming that every request exercises a different code path. So the point being that it's extremely hard to do testing as the scale increases, and it becomes more and more expensive to get good coverage as the size or complexity of the system increases. So we need more advanced automated techniques that do not rely on developers to write tests. None of this is to say that you should not write tests. You should write as many tests as you can, but you should be cognizant of the fact that the impact that you're making at every level is becoming increasingly small, and tools like Diffie can help you when you get to those scales and those levels of complexity. So the approach we decided to take with Diffie was that if we look at the anatomy of a test, you have an input that triggers a certain behavior, and then you make some assertions on that behavior, right? So the behavior that we care about the most is one that is most likely to be exercised in production, which is why we at Twitter prefer using sampled production traffic to drive that behavior for untested code. And then the question becomes, OK, now I'm driving the behavior in my untested code, but how do I make the assertions that the behavior is right? And the answer is, well, you compare it to the old version of the code, assuming that the old version of the code that's currently in production did not have something bad in it. And as long as the behavior is similar enough to the old code, then you haven't had any regressions. We'll sidestep the problem of setting up environments and those things for the purpose of this conversation. But if you're interested in that stuff, come talk to me afterwards. So This approach, however, inherently has a big problem of being extremely noisy. So when let's say you send the same request to your old code and your new code, right? Your old version of the service and the new version of the service. And in the response, the service returns a server-generated timestamp, right? Those two timestamps will never be the same. And so you think that, hey, these responses are different. There must be something wrong with my service. Well, that's not the case, right? There can be other sources of noise if your code has random generators in it, or if your instances that you're testing are backed by live production data that's moving, then you could have right in between read contentions, and those race conditions can themselves be a source of noise in the responses that you get back. So without having a good story for noise cancellation and this sort of an approach, the work on the developer side amounts to looking for a needle in a haystack. And noise cancellation is paramount when you're trying to do something like this. So how do we do that? Well, we say that take a bunch of traffic and multicast it to 3 instances of your service. So the candidate here is running your new code. The primary and secondary are both running the same version of the old code, right? So there's nothing different about these 2 instances. And the point is that when you do the comparison between the responses that come back from your candidate and primary, you see a bunch of raw differences. But when you compare the old code to itself by comparing primary and secondary, you will see differences here. And those differences will highlight which parts of the response are inherently noisy and should be subtracted out from the raw differences so that the developer can focus on the filtered differences that cannot be explained by noise. So let me do a quick demo here. This is what Diffie looks like for one of our services. This is an example service that's running. And you can see here that all the endpoints are listed for this example service, and you're seeing the entire response object tree, and you're seeing aggregations of all the different kinds of differences that this service has seen. So if we look at this one, for example, it's a very small difference. If you want to deep dive and see what exactly triggered the behavior to be different, you have the full-blown request, the full-blown responses for debugging purposes. And the exclusion logic is what allows us to say that, OK, this whole stuff is OK to ignore because primary and secondary are disagreeing with each other for this particular type of error almost as often as primary and candidate are disagreeing with each other, right? So by doing that comparison of aggregations of statistics across different types of errors, we're able to do a good job of noise cancellation. And so coming back to the developer, the real engineering organization side of the world, the natural thing that came to us from our customers was that, why don't you automate this? I mean, I love being able to test my branch against master, but I also want to see what's going on with master compared to what's currently in production. So I want to come into work every day and receive an email every morning that tells me that, hey, last night I did this comparison for you, and here's all the changes, all the differences in behavior that I've observed. And if any of these differences are unintended, then you have the opportunity to take preemptive action against these things before they get deployed to production. So we did that, and now we're able to apply this whole noise cancellation thing and send these rich emails out to our customers. And you can click on one of these, and it takes you straight to what the error is, and you can deep dive and debug, as I just showed you guys. So moving on. The next thing that comes naturally as you're setting up, as you're multicasting traffic to old and new versions of the code is you're also replaying the exact same load in lockstep against your new code and your previous code. So can you then look at the metrics coming out of those boxes, the performance metrics coming out of those boxes, and do some kind of analysis to figure out if there's been a performance regression, right? And if you're on the Finagle stack, you'll see that you export a lot of metrics. And it becomes humanly impossible for someone to eyeball these individual metrics. And in fact, humans are terrible at eyeballing metrics. So you want a machine to do this job and go through all the thousands of metrics that your service is exporting and highlight the ones to you that actually have significant deviations from the old code, right? But in this world, we start thinking about the comparison in slightly different ways, because we're now talking about performance, and there's a lot more susceptibility to noise. So our candidate now becomes an entire test cluster. So you have n number of machines in the test cluster. And then your primary and secondary become your reference cluster. So you have n number of machines in your reference cluster. So for the same time series type, you get a cluster of time series from the test cluster, a cluster of time series from the reference cluster, and you build this classifier that is able to analyze all of these clusters of time series and make the decision as to whether or not there's been a significant deviation in the metric, the time series data. And it categorizes the time series as passed, ignored if there is insufficient data, or failed if there's definitely something wrong with something like this, right? And so as we were doing this whole classifier analysis, we built a whole bunch of different classifiers to see which one worked. And turns out each one of these has its own set of blind spots. It works for some things, but then doesn't work for the other kinds of things. And really what we ended up doing was coming up with an ensemble approach where composing these metrics in a meaningful way gives us the ability to reduce the false positive rate significantly and give meaningful data back to the user. So in this case, what's happening is that I'm saying there needs to be at least 50 samples in order for the classifier to do anything with this. Then there is this relative threshold classifier, which is just taking at the relative deviation between, the relative difference between the variations within each of the time series clusters. The absolute threshold classifier is taking into account the distance between the medians of the individual clusters. And finally, the MAD classifier, as the name suggests, is looking at the median distance of each of the samples from the median of the cluster. And that probably does not make sense right off the bat, so I encourage you to look it up on Wikipedia. I'm not lying, this is a real thing. So what does this look like to one of our customers? So along the vein of automation, when we send you the email about all the correctness analysis stuff, we're also able to send you an email that lists all the different metrics that we flagged. So in this example service, we saw that there's of the order of 6,000 plus metrics, and of which we were able to filter the set down to 32. So if we click on, let's pick one randomly and click on it. OK, sometime today. Right, so you can see here that the primary and secondary are pretty much in lockstep with each other. But the candidate is significantly far off, right? So this is the classifier doing its job and saying that, hey, I had a bunch of test time series, a bunch of reference time series, and I know which one's the candidate and which one's the primary, secondary. So I'm going to use that context to give you feedback on this particular metric, whatever this is. Hopefully, this is something that makes sense to the application developer. But from Diffie's point of view, all we're doing is analyzing raw time series data and highlighting these sorts of metrics back to the user. Right. So we have some more work in progress along these lines. One question that might come to mind is, what do you do if you have write paths, right? What if, how do you replay write traffic to a service? What do you do with the environment when the service has downstream dependencies, which inevitably it will? And so, Finagle has this really cool feature where you can, add tracers to your service and use those tracers to not only intercept the request, but also all the downstream interactions triggered by that request, right? So in essence, when we do our recording in production for the traffic, we're also recording all the behavior or all the interactions that happen with the environment, right? And so as a result, when we come back to staging to do this sort of regression analysis, we're able to replay the environment exactly as it was in production. So we have all the RPCs, downstream RPCs recorded from production. We also have the timing data recorded from production, so we're able to simulate the same delays, the performance characteristics as if it was production. And then we're able to even process write paths using that sort of an approach. But again, like this is work in progress. This is not something that's in Diffie right now. Questions?
Hand around the mic.
Sure.
So just
I've
talk
got
loud.
a loud voice. It's really neat stuff, let me say. I might have missed it at the beginning. This project is open source now? Is that, we?
Not yet. We're working on it. We are very close to it. We are very close to open sourcing it.
Do you sort of see this being turned into like CD anywhere along the line? Continuous deployment?
Sure. Let me answer that. So in terms of CE, there's been a few efforts within the company where they've wanted to automatically promote artifacts saying that Diffie didn't find any regressions, this is clean. And along those lines, we don't have any tooling that comes with the box, out of the box, but we have exposed APIs. So you can get sort of the aggregate results from Diffie with an overview report, and then based on the report, the external tool can make the decision as to what to do with it. CI systems tend to be diverse, so rather than go vertically integrated in that direction, we decided to expose an API and leave it up to the developers to figure out how to consume it.
Thanks.
Yep. Any other questions? All right. I'll just do it in order of proximity.
Does the act of measuring the system affect the system performance?
Does the act
Measuring and capturing the metrics.
All right. Good question. So does the act of measuring the system affect the performance? So we're only, when you say measuring, I will assume it's like sampling traffic, right? So we only sample traffic from production, but all the experiment that we're doing, the comparison that we're doing is completely isolated in staging, right? And there's no sampling going on in staging whatsoever. And there is a sort of the concern about production performance being degraded as a result of this recording happening. But typically what we see is that there's a very small fraction of the traffic that needs to be sampled anyway, because you've got thousands of machines in a cluster, and if you sample 1%, you have 10 instances worth of load, and that's more than enough to do whatever kind of comparison, and barely shows up anywhere in the performance of the production systems. When we're replaying and measuring the responses, we're doing all of that at the networking layer as an external client, right? So there is no impact on the performance of the thing that is being tested itself, right? Someone at the back had the question, so I'm just going to go up to them real quick.
Thanks. What's your story on distinguishing changes in a new version of software that were intended from changes that happened because I broke something, right? If I change a piece of software, I do it because I want to change some behavior. Might that be a buggy behavior or not? How do you deal with that?
Right. Excellent question. So we don't have a story, unfortunately. The story is that Diffie is just trying to highlight any changes in behavior, right? And if it doesn't find any differences, then the artifact may be, for example, automatically promoted. But if it finds any differences, those differences might be very well intended by the developer. And so a human has to override and sign off on those changes and say that, yes, I know what I'm doing. This change actually needs to go out in production. But yeah, I mean, unfortunately, there is no easy way for Diffie to figure out that a difference that it's seeing in behavior is intended or not.
Do you also mark it suspicious if it becomes way quicker or way faster?
Way quicker or way faster? Okay.
If the performance increases.
Oh, yeah. So that's again a good question. So we currently do not distinguish between positive regressions and negative regressions. So if, for example, you work really hard and your system is now processing at half the latency and the P50 is down by 50%, we'll flag that as a regression. Because when we deal with time series data, we don't take any domain knowledge from the developers. We're just taking everything. And we could potentially do some smarts around, okay, if the name has the word latency in it, then flag things as green versus red regressions. But unfortunately, right now, we don't. I mean, it's something that we could look into, though. Yeah. Any other questions? All right.
Great. Thank you very much.